This is Mr. Precella, and welcome to Math 1324. This is the first topic in the course, so this is the first time you would have been hearing my voice, especially if you're enrolled in the online class. So welcome to the course. In this semester we'll be looking at applications of all that algebra you learned in high school or wherever you've learned your algebra. It's a very nice application course, and we're going to begin the course looking at applications of functions. In a previous algebra course, somewhere along the way, you discussed linear functions. A function is a rule that assigns to each x value one and only one y value. A linear function can be written in the form y equals mx plus b, or the letter y might be written with a f of x. So y equals mx plus b, or f of x equals mx plus b is a linear function, and m is the slope of the line, and b is what we call the y-intercept. Well, what we're going to do first is look at some particular linear functions that have business applications, in particular the cost function, the revenue function, and the profit function. The cost function is in the form c of x instead of f of x equals mx plus b, and this is where m, well, it's the slope of the line. That's what we would say if we were just talking about lines. But for a cost function, m is called the marginal cost per item. In terms of lines, b is the y-intercept. In terms of a cost function, it's the fixed costs. Every sort of business has two types of costs associated with it. The fixed costs and then the marginal cost per item. The fixed cost would be things like rent on the building if you had some sort of store, where every month you've got to pay those fixed costs, whether you're open or not, whether you're selling any items or not. The marginal cost per item would be the cost of supplies that you use to make the items. For instance, if you had a restaurant selling tacos, then the fixed cost would be things like rent on that building or the mortgage payment on that building. The marginal cost per item, that would be the cost of supplies. If you were going to take a week off, you wouldn't buy the supplies to make the tacos, but you would still have to pay the rent. Okay? That's the cost function. The revenue function calculates the amount of money that a business brings in. Okay? R of x is equal to P times x. This is a lowercase p, and I'm writing it as a lowercase p, and you don't switch it to capital P because we're going to use a capital P to denote profit. This lowercase p is the selling price, and I haven't mentioned, but x is always quantity. In economics, generally x is on the x-axis, that's quantity, and the y-axis, if you think of the x-axis and the y-axis is dollars. So selling price times quantity. Going back to that taco restaurant that you have, if you sold 500 tacos at $2 a taco, then you've brought in $1,000. Now that's not your profit, okay? To calculate profit, you would need to subtract the revenue and the cost. If you sold 500 tacos at $200 a taco, at $2 a taco, and bring in $1,000, that wouldn't be your profit. You would have to say revenue minus the cost. How much did it cost for you to make those tacos? Okay? Now, a business breaks even. Ooh, they cut the lights off on me in this building. Okay, here. A business breaks even, and that's going to happen periodically through these. By the way, the lights will cut off because the motion detector in the room won't detect that there's enough. It'll think there's no one in here. But the break even occurs when a profit is zero, or another way you might define break even, if a business's revenue equals their cost. If the amount of money they're taking in equals the amount of money they're spending, they're not making a profit, but at the same time they're not making a loss. Okay. So now we're using My Math Lab to do our homework. So hopefully all of you have logged into My Math Lab. Well, if you're watching this video, you're either looking at it directly on YouTube or you've logged into My Math Lab and follow the link from My Math Lab to YouTube. So hopefully you've joined the My Math Lab course so you can be getting your homework and so forth. So let's see. Here are some problems we're going to do. Problem number 1. It says, a parking garage charges a fee of $5 plus $1.50 per half hour. Choose the function which represents the total cost for X hours. Well, this one's a little tricky. I guess it's a bad thing. The very first problem I do this semester, I say it's a little tricky. This is telling you the cost per half hour. We want to have a function written in terms of the cost for hours. So $1.50 per half hour would be the same thing as $3 per hour. So to write a cost function, we would say C of X equals, it's $5 plus $3 per hour. If X is the number of hours, 3X. Or 3X plus 5. Why did I write it like this rather than 3X plus 5, which is more the way we defined it right there? Why did I write it like this? Well, because that's how the answer choice was written. This is a multiple choice problem, it looks like. Okay. Problem number 2 says, okay, find the cost function. We're told the fixed cost is $100 and 50 items cost $600. Oh, okay. To write a cost function, I think I'm going to, I better get another sheet of paper to work this one. Okay, so let me see. Get some paper. And I'm doing this problem number 2. Someone was telling me, a friend of mine that works over at the university was telling me that average student attention span is only 10 minutes, and these videos, some of them are going to go over 10 minutes, quite a bit over 10 minutes. So if you can't handle the long attention, or if you can't handle the long video, well, stop it and then just remember where you are and pick up later. Okay? Some of the videos I'll break up into smaller pieces, but we'll see. Okay, so problem number 2. We want to write a cost function, which is in the form mx plus b. B is that fixed cost. So we were told that the fixed cost is $100. So we can go ahead and put 100 in for B. But we weren't told the marginal cost, and that's what we need. So to find that marginal cost, I'm going to use this information right here. 50 items cost $600. Which one of these variables is quantity? Well, X. So if we plug 50 in for X, we're going to get a cost of 600. So I'm plugging 600 in for the cost. In place of X, I'm putting 50. And now we have an equation that you know how to solve for M. How would we solve this for M? Well, I'd subtract 100 from each side. So we have 500 equals 50M. And then divide both sides by 50. So M is 10. That means, once you know M is 10, our cost function would be 10x plus 100. So the marginal cost per item is $10. The fixed cost is 100. So in this box right here, you would type 10x plus 100. Okay. We're looking at cost. This is cost profit revenue analysis. Okay. Cost profit revenue analysis. Let's look at number 3 now. Problem number 3. The dispatch tool works spends $1,800. Eventually I might do the calculator, so I'm rummaging around looking for one. You hear all the movement. The dispatch tool work spends, no, $18,000. We're doing this problem right here, number 3. To produce 120 items. Okay, so they're spending $18,000 to produce 120 items, achieving a marginal cost of $130. Find the linear cost. Well, this one's sort of like number 2, except on number 2 we were given the fixed cost. Here we're given the marginal cost. So which one of these boxes will we fill in with 130 right off? This one right here. It's C of x equals mx plus b. And we know that M, the marginal cost, is $130. So now we need to find B. How do we do that? Well, we're given this piece of information. It costs $18,000 to produce 120 parts. So the 120 is the quantity. The 18,000 is the cost. So 130 times 120 is 15,600. So subtract 15,600 from both sides. and we get B is 2,400. So what's this cost function here? It's 130x, so 130 goes right there, plus B, 2,400. Number 4. Cost function is given. Find the average cost per item. So a cost function is given. Find the average cost per item. Well, how would you calculate an average cost? Okay. Well, to calculate an average, you're going to divide. Generally, in mathematics, if there's a horizontal line up above something, you read that as average. So this notation I just wrote here is average cost equals total cost over quantity. Using our symbolic notation, the total cost would just be C of X. The quantity is X. So we want to know if it costs, or if 50 items are produced, what's the average cost per item? That's going to be C of 50 divided by 50. Now remember what this notation means with functions. Whatever number's in the parentheses, you plug that in for X. So I'll show that. You plug this number into the cost function, 16 times 50 plus 1,600, and then divide by 50. So what's 16 times 50 plus 1,600? That would be 2,400 over 50, 48. So it's costing $2,400 to produce these 50 items. So on the average, it's costing $48 per item. Okay? So that's called the average cost function. You're taking the total cost, $2,400, and dividing by the number of items being produced, 50. Look through. I've printed out problems like you might encounter in your homework. I'm just going to be working through some examples. Number 5. In the cost function below, C of X is the cost of producing X items. Find the average cost per item. Okay, so this is another average cost per item problem. So you're going to take each one of these numbers and plug it in for X. So plug 200 in for X and then divide by 200. When you plug 200 in for X, here I'll write it out one time. 8.6 times 200 plus 9,600. I plug 200 in here for X, and that's going to give me the total cost. So 8.6 times 200 plus 9,600. I'm using a TI-83 calculator. I guess those are so old. Most people have 84 now. So a TI, some sort of calculator like this, a TI-83 or 84 is a good calculator. So 11,320. So it costs $11,320 to produce those 200 items. So on the whole, or on the average, it's costing $56.60 per item. Now, what's the cost to produce 2,000 items? Well, you're going to do the same thing. Plug 2,000 in for X, and then divide by 200. So I'm plugging 2,000 in for X. Oh, I know there's sort of a glare at times on this calculator. So it would be 8.6 times 2,000 plus 9,600. That's 26,800. Divide by 2,000, not 200. Divided by 2,000, $13.40. Oh, wow. Notice how this average cost per item went down dramatically from 56.6 to 13.4. So it looks like the more items that are produced, the lower the average cost per item. And that's correct, because when you're only producing a few items, this 9,600 fixed cost, that's an awful big chunk of the total cost. But the more items you produce, there it goes, more items you produce, that 9,600 becomes less significant. So let's see what this one's going to be. If we produce 5,000 items, that would be the total cost of 5,000 items divided by 5,000. To get that total cost of 5,000 items, you're just going to plug in 5,000 right here. It would be 8.6 times 5,000 plus 9,600, 52,600 divided by 5,000, $10.52. You'll notice how the average cost per item decreases as the quantity produced increases. If we kept increasing the quantity produced, this 9,600 is going to become less and less. Eventually, it will approach, for real large values of X, this 9,600 is going to be so negligent that the average cost is going to start approaching that marginal cost, 8.6. Okay? That's something the big box stores figured out a long time ago, that they could produce and sell more. That lowers the average cost per item. And of course, if they can get it produced in a third world country and pay 2 cents a day, that helps lower their costs also. Okay? But that's sort of a joke, but not really. Let's see, what about this one? Number 6. The total cost is, what's the fixed cost? Well, that's $96,000. Remember, the fixed costs are the y-intercept. The marginal cost is the coefficient on X. So right here in this box, you would write 43. And then it asks, okay, what's the total cost of producing 1,000 books? What's the total cost of producing 31,000 books? Oh, this is a really good problem. So the total cost of producing 1,000 books, you plug 1,000 in to the cost function. That's how you get this answer right here. Oh, let me move it on up. So you're going to plug in 1,000 right here. 43 43 times 1,000 plus 96,000. Oops, 96,000. So that's 139,000. That's the cost of producing 1,000 books. Now to find the cost of producing 31,000 books, you plug 31,000 in for X. 43 times 31,000 plus 96,000. So this 139,000 is this first box here. The cost of producing 31,000, ooh, what is that? 1,429,000. 1,429,000. Now, when you type this into my math lab, you don't put the commas. Okay. And then it asks, okay, what's the average cost? To find that average cost, you're going to divide each of these. If it costs 139,000 to produce 1,000 books, 139,000 divided by 1,000 would be just 139. How did I, can y'all tell that's a 139 there? Maybe I better write out how I got that. And so this box right here, doing right here, you're taking the cost of 1,000 books and dividing it by 1,000. The cost of producing 1,000 books was found in the previous problem. 139,000 divided by 1,000, that's 139. So it cost $139 on the average, $139 per book. Now that one I could do in my head. This next one, what's the average cost when 31,000 books are produced? Well, we found that the average cost is the total cost of producing at 31,000 is 1,429,000. So divide that by 31,000. Wow, sometimes the light doesn't go off, and then other times it's going off every 5 or every 2 minutes, huh? $46, and how do we talk? Round to 2 decimal places. So can y'all see that? $46, and would y'all round that to 10 cents? See, notice how low the average cost per item is when you produce a huge number of these books. Okay? Whereas if you only produce 1,000 books, then the average cost per item is $139. Some good cost revenue analysis. Let's see. 7 and 8 look like the same type of problem, don't they? Okay, it says what's the cost function? And notice they give you the fixed cost, the marginal cost, and what the item's selling for. That's going back to this first stuff I did here. So far, really all we've been working with is cost. Marginal cost times X. Ooh, right there. Marginal cost times X plus the fixed cost. So that would be C of X equals, the marginal cost is 13X plus 500. Then we're asked, okay, what's the revenue function? Well, revenue is that selling price times X. The selling price here is 25, so just 25X. Now the profit, it takes a little bit of work. Profit is revenue minus cost. So, I'm getting sort of low down here. So I'm going to go revenue, then a minus sign, the cost function. So I'll just continue this right up here. The revenue function was 25x. Can y'all see this? Yeah. Then the green minus, I'm going revenue minus cost. The cost is 13x plus 500. And when I have it written like that, that's not completely right. I want to subtract all of this. So if I put parentheses around there, does that hint tell you what I'm trying to say we need to do here? We need to distribute this minus. Don't just subtract the 13x, you should subtract the 500 also. So we'd have 25x minus 13x minus 500, which is 12x minus 500. And that's your profit function. Flip through. Number 8 is the same type of problem. Now to do the next one, it's going to ask us something about profit and also break even. We're going to do a little break even analysis. Remember, there's two ways we can define break even. We can say a business breaks even if the profit is 0, or if the revenue equals the cost. On problem number 9, let's look at what we're given here. We're told, okay, we have a company, the revenue in millions of dollars. From the sale of X units at a home supply outlet is given by. So there's the revenue function. And here's the profit in terms of millions of dollars. From the sale of X units, it's given 0.082x minus 1.7. And we're told to find the cost function. Well, let's look at this general profit formula. Profit equals revenue minus cost. We're trying to find the cost function. See, we're already given the profit function. So if we want to solve this for the cost function, here's what I'm going to do. I'm going to get this C of x by itself. That means I want to get rid of this minus sign here, and I want that C of x completely by itself. The way I'm going to do this, these little arrows, what I'm saying is add C of x to both sides and subtract P of x. I'm not sure what your former algebra teachers have said, but you can hear people, or what some people might say is, move it across the equal sign and change the sign. So here's C of x. The cost function is revenue minus profit. What I'm actually doing there is, where's my invisible orange ink? This orange ink is very dim. Add C of x to both sides. So that is the C of x here. And subtract P of x from both sides. Or just move those things across the equal sign and change the sign. So C of x equals, the revenue function is 0.28x, then a minus, what's that? Profit function P of x, 0.082x minus 1.7. 1.7. Notice how I put that in parentheses because we need to distribute that red minus. So distributing that red minus, we'd have 0.28x minus 0.082x and a plus 1.7. So I'm going to punch in 0.28 minus 0.082. That's a 0.198x plus 1.7. That's our cost function. And we'll put it right here. 0.198x plus 1.7. Now the next thing it asks is the break-even. Where does the break-even point occur? How many items do they need to produce and sell just to break even? They're not going to actually make a profit. They're just trying to break even. And there's two ways we could do that. Either take P of X and set it to 0, or take R of X, set it equal to C of C of X. Well, I'm going to do this all right here. Since I think it'd be easier in this case just to set P of X to 0. If you think it'd be easier to put the 0.28x equal to 0.198x plus 1.7, that's okay. However you think it's easier. I'm thinking, since we were given the P of X, just set it to 0 and solve this for X. Here I am doing that arrow thing again. I'm moving the 1.7 over, or adding 1.7 to both sides. Oops, that should be an equals. Okay, an equals there. And then divide both sides by 0.082. So we have 1.7 divided by 0.082. I'm getting 20.7317 ... It says round to the nearest thousandth. So how would I round this? Tenths, hundredths, thousandths. That 1, would we leave it as a 1 or round it to a 2? Well, you're going to round it up to a 2. We're going to use traditional rules of rounding, which means look at math rules for rounding. Look over here, round it up. 20.732. Sometimes students tell me, well, as the semester progresses, we rounded differently in our accounting class or something. No, this is in a math course. And in math, we always use the same rule for rounding. The number after the 1 is 5 or bigger, you round it up. If it's 4 or smaller, you round down. See, number 10. Suppose you are the manager of a firm. The accounting department has provided cost estimates and the sales department sales estimates on a new product. Analyze the data they give you, determine what it takes to break even, and decide whether to go ahead with production. So the first thing we're told to do is find the break even. Well, on this one, since we're not given P of X, to do the break even here, I would just set R of X equal to C of X. 480x equals 360x plus 6600. how do we do this? I would subtract 360. 480 minus 360 is 120. And then what would I do now to solve for x? I have 120x equals 6,600. Would I divide both sides by 120? Yeah, that's what I do. So 6,600 divided by 120 is 55. So to break even, they're going to have to produce and sell 55 units. Whatever a unit is. It might be items, or it might be 55 dozen items, or maybe 55 boxes of 1,000. I don't know, but 55 units. If the company can produce and sell no more than 32 units, because of some sort of production requirements, they can't make more than 32 units, period. What should they try producing this stuff? Answer would be no. Okay? If they're going to have to produce and sell 55 units just to break even, and they can only produce 32 at most, don't produce it. Okay? Now, a little supply and demand. Supply and demand. When we talk about supply and demand curves, the supply curves take the view of the business. Demand takes the view of the consumers. So if this X is quantity and Y is money, okay, or the cost, from the view of a supplier, if you were going to produce something, you were the one making the stuff, if the only way you can make it, sell it, would be if you had to price it at $0, then you would not want to be making any of those. In general, a supply curve looks something like this. And I'm saying it's curve, and I've drawn it as a line, okay, but a supply function. This takes the view of the supplier, which, as the price increases, okay, this is quantity, price. Okay? As the as the price goes up, the amount they're willing to produce is high. Okay? The more they can sell it for, the more they want to make. Whereas the demand curve takes the point of view from the consumer. That's you out there. The consumer, when the price is real high, they don't want to produce, no one wants to buy it. Okay? Suppose you walk past a Coke machine and they had a sign, Coca-Cola's for $10 million. You're not going to buy it. Okay? Most people wouldn't pay $10 million for one Coca-Cola. But as the price goes down, suppose you walk past that Coca-Cola machine, and there was a sign there, okay, Coca-Cola's 5 cents. Then even if you're not really thirsty, you might think, oh, 5 cents, I'll take that Coca-Cola. In general, a demand curve looks like that. The higher the price, the smaller the X value. The lower the price, notice more and more people want to buy it, the cheaper it gets. This point of intersection is referred to as the equilibrium point. Market equilibrium occurs when supply equals demand. And problem number 11, we're given a supply curve, notice, looks like that, and a demand curve. And it says, at what price are 15 items demanded? At what price are 15 items demanded? Okay, so 15, that's the quantity, so that would be here. Oh wait, I misread the problem. At what price are 15 items supplied? Supplied. Okay, so 15 items would be supplied at a price of, ooh, can y'all read this graph? It's sort of hard. $160. Okay. Notice, at $160, the producer is willing to make 15 items. Is anyone going to buy it at that price now, though? No. Okay. Let's see. Number 12. Use the supply and demand curves to find the equilibrium quantity and the equilibrium price. So you just got to look at the point of intersection. Remember, price is vertical, quantity here. So let's see, right between, how much, what is each one of these little marks? 40 down here? 40, 80, 120, 160, so 200. Would that be here or here? Well, that would be quantity, 200. And what's the, how are they incrementing price? Ooh, is that by $24? 24, 48, 24. So each one of these marks is $24. So 96 plus 24 is 120. So when the supplier produces 120 items, excuse me, 200 items, and the price is $120, that's when there's not going to be any shortfall or excess stocking, okay? So market equilibrium is the desired spot. That's where there's not going to be a shortage, customers demanding and there's not any. And at the same time, there's not going to be a lot of them just sitting on the shelves not being sold. Now, that was linear cost functions, or linear functions. Somewhere along your life, you would have looked at quadratic functions. A quadratic function has an x squared in it. And graph of a quadratic function is a parabola. It either opens up or it opens down. So U-shaped figure. It opens up if the number a is positive, and it opens down if a is negative. And that turning point, the vertex, there's a little formula for the vertex. To calculate the x coordinate of the vertex, it's minus b over 2a. And I'm going to take a short break, and we'll pick up with these quadratic functions in a little bit. Okay? So I'll be right back, taking a little break right now.